spaceships are launched. Students are working on developing a new type of rocket motor that's cheaper, safer, and better than the ones that NASA now uses. It's a hands-on project where students not only build the motors and mix the fuel, but they have a hair-raising experience of setting them off. Pam White has our science and technology report.
Building a better mousetrap, or in this case a hybrid rocket motor, are a group of U of A students working on an alternative that could revolutionize the way spaceships are launched.
And liftoff. I'm absolutely convinced this will be the wave of the future because it is safer, cheaper, lighter, and controllable.
Pitch program is in, roll program
Standard
is in.
rocket motors are usually made with liquid or solid fuel.
Spacecraft is on its way to Saturn.
For any propellant or rocket motor to work, you need the fuel and the oxidizer, and the two must come together to burn, much like gasoline and air in an automobile.
0 and liftoff of the Athena 2 rocket and the Lunar Prospector spacecraft on a voyage to rediscover the moon.
In a rocket motor with solid fuel, the oxidizer and fuel are together.
So the moment you ignite them, they go. That makes them very dangerous because a small accident could ignite the entire thing. In a hybrid, the solid is separate, the fuel, and the liquid or the oxidizer is separate. So when you put them together, they burn and produce the thrust, and when you don't feel like having it, you can shut off the oxidizer and the motor terminates. And you can stop, restart, any number of times. You can also throttle it.
Dr. Ramohalli says they're so safe, you can actually carry it around in a suitcase.
Maybe something like the Challenger disaster wouldn't have happened.
Yes, that's absolutely right. I don't like to give that as an example. It's a very sad thing that should not have happened. It happened. But it is very true that if we had only used hybrids, that accident would not have occurred.
Dr. Ramohalli spearheaded the program here for almost a decade. A prize student, Vanessa Duke. Her specialty, coming up with the right fuel.
And it takes about an hour to do the fuel grain, and we just mix ingredients in the mixer. We let it cure, which means we let it harden, and that takes about 72 hours, so a couple days for it to cure, and then we just test them.
90% of it's just tedium. Casting the motors, that takes a couple days. Designing the apparatus, that could take years. But when everything's said and done, the day that you do the firing is just it's amazing.
To test it, it's taken outside for what's called a static firing.
The core of your being, it rattles you. And it's just something that's not natural. You're very uncomfortable with it because you know the power is there. Even though it's safe, and even though mentally you know it's safe, just that animal part of your brain just says, get away. And that's where the thrill is.
Even more